This is an A-level pure question on numerical methods using the Newton-Raphson method. The equation 2x cubed plus x squared minus 1 equals 0 has exactly one real root. Part A, show that for this equation the Newton-Raphson formula can be written in this form here. That's x sub n plus 1 is equal to 4x sub n cubed plus x sub n squared plus 1 all over 6x sub n squared plus 2x sub n. So I've just got a reminder of the Newton-Raphson formula here. So the first thing I'm going to do in this question is I'm going to let f of xn equal to this polynomial here and just put all the n's in as well. So 2x cubed plus x squared minus 1. So from there I can differentiate it to find f of x or f dash of x because that's what I need at the bottom. So don't forget all the n's. So I'll have 6xn squared plus 2xn, and then the minus 1 goes. And so I can now write down that xn plus 1 is equal to xn minus, and it's the f of x part, and that's going to be divided by the f dash of x, which is the 6x squared part at the bottom. Now this doesn't quite get me to what I want here because this doesn't have an x sub n at the beginning. So this has been combined into this fraction, and also I can see a 4x cubed here, and that's a 2x cubed. So my next step is going to be to write this in a form that I can combine it with the rest of the algebraic fraction. So I'm going to take this xn and times the top and the bottom, because this is like over 1, by this denominator here. So I'll have xn plus 1 is equal to, so I'll have xn times it by the denominator, so 6x squared plus 2x, and then the same at the bottom, 6x squared plus 2x, and then subtract this the original algebraic fraction I had there, so 2x cubed plus x squared minus 1 all over that denominator, 6x squared plus 2x. So now the two can go together, so I'll have n, or xn plus 1 is equal to, now I'm going to expand the brackets here, so I will have 6x cubed n plus 2x squared n, and then minus the 2x cubed plus x squared minus 1. So this is all over the same denominator, so the 6x squared plus 2x. So now I'll have 6x cubed minus 2x cubed, so that's the 4x cubed. So I think it now gets it in the form that we want. So we've got 4x cubed n, then we've got 2x squared minus the x squared, that's just going to be x squared, so plus x squared n, and then you've got minus negative 1, so it becomes plus 1, and then the same denominator as before, 6x squared n plus 2x n. So we've got the result that they want as required. Using the formula given in part A, and here's the formula that was given in part A, with x sub 1 equal to 1, part B, find the values of x sub 2 and x sub 3. So this is all going to be done on a calculator, but you should always show the first substitution. So for x2, we're not just going to do it on a calculator, we're actually going to write down the substitution here. So all of the x's for x sub 2, here xn's will be replaced with x sub 1, which is 1. So I'll have 4 times by 1 cubed plus 1 squared plus 1 all over 6 times by 1 squared plus 2 times by 1. So even though I may use the calculator to work this out, I'm still going to write down the substitution here. So I can probably do this without a calculator more quickly actually. This is 6 over 8, so 3/4. So I'll just make it clear that I've got x2 equal to 3/4. And then for x3 I can do that on the calculator. Now I've done a video before, I'll put a link in the description about how you can use your calculator to quickly work out these iterative values. And using a calculator you'll just get x3 as 2/3. I'll just highlight those values. x2 3/4, x3 2/3. In part C, explain why for this question a Newton-Raphson method cannot be used with x1 equals 0. Now if I were to put x1 equal to 0 into here, I'd end up with 0 in the denominator. Now you can't just say that there's going to be a 0 in the denominator. Why is that happening? Remember, this is f of x, it's not f dash of x. So when we've got 0 in the denominator, basically we're getting f dash of x equal to 0. Now what does that mean? That means that the original equation, that polynomial, has some sort of turning point or stationary point at x equals 0, and that's what we need to explain. So writing that fully, since f dash of x equals 0, f of x has a stationary point at x equals 0, and we can't use Newton-Raphson where we have these stationary points. In other words, if we were to look at the tangent at that point of the curve, it will be horizontal. And the whole point of using Newton-Raphson, maybe I'll draw a little sketch down here, is that we want the tangents to give us the next x value, and that's only going to happen if they cross the x-axis. So let's say we had a curve like this, for example. So, if I had a tangent here using Newton-Raphson, that's fine, because then I would use this to find my next x value. That's not a problem. But if I have a tangent here, which is what will happen when f of x is equal to 0, this is never going to cross the x-axis. I'm not going to get that next x value which Newton-Raphson requires. So this is one of the limitations of using Newton-Raphson. But yeah, the point is, the whole point is it's got a stationary point. We can explain it that way, and so that tangent is not crossing the axis, not giving us that next x value.